The broadcast is now starting. All attendees are in listen-only mode.
I would like to welcome everybody on this next webinar on the iChemist Safety Center Safety Law. This particular issue will highlight some important information about key lessons from incidents related to dust explosions. Welcome everybody, my name is Susanna Gyenes. I am the Deputy to the Director of the iChemist Safety Center. These webinars we organize regularly because we think it's really important to share the knowledge and share the information about different topics that we publish. And also, this is a good opportunity not only to read the material, but also engage in conversation with each other and ask questions, and also interactive way to share your knowledge and your experience about this particular topic. Now, it is about dust explosions, and from the names I recognize that many of you are really expert in this area. What I would like to do today is give general information and review, discussing 2 case studies, and then what can I do in the next session. And then I'm interested in whether you have further insights, and further information that you would like to share with me and with others that you think is crucial in order to understand better the conditions of dust explosions, industries that are affected by dust explosions, as we have seen in recent, I think, couple of months, that we have seen that there are many occasions where dust explosions occurred. And then I decided, right, this is the time to publish a safety law. And so with that, I would like to highly encourage you to use the questions box or chat box, whichever you can see on your platform, and share your ideas, comments throughout the presentation. So normally when I present, okay, just give me a second because the sharing stopped. I hope you can see it now. Nope. Excuse me, something happened in the system. All right, now you can see it. Okay, so when I describe the topic, then normally I put typically I put a definition on the screen so that you see that what I'm going to talk about. But I think the most important, and everybody can relate with, the Pentagon, the dust explosion Pentagon, or explosion Pentagon, that I put here, because this is how you can best describe dust explosions. So what it is about. So dust explosions, interestingly, can occur in any industrial site which actually handles bulk powders. Dusts involved include common products, which is really interesting, and that's why we published the loss prevention bulletin on a special issue on food related accidents, and many of them actually describe dust explosion cases. So these are the products such as sugar, flour, cocoa, chemicals, dyestuffs, pharmaceuticals, plastics, metals, for example, aluminium and magnesium, and other traditional fuels such as coal and wood. And if you have more examples, then feel free to type in the questions box. I would be really interested in seeing your comments where you have faced such a situation. And there are 5 conditions, as you can see on the explosion Pentagon, for a dust explosion to occur, which are the presence of combustible dust, oxidant, ignition source, concentration of dust mixed in the air within explosive range and confinement. So these are the conditions. And there are two broad categories of dust explosions, which are primary and secondary. And why is it important to discuss these two? Because a dust explosion initiated under conditions of confinement is called a primary dust explosion, and the force from that primary explosion may disturb surrounding dust, forming another dust cloud, and the flame from the primary explosion subsequently ignites the suspended dust cloud. And that's why secondary explosions are also initiated under conditions of confinement, and that's why generally more destructive than the primary explosion. I think that most of you have seen such videos or the devastation after such an explosion, that you can see that there is really a big damage that is caused by the secondary explosion. Now, I brought you today two case studies, and this one, normally I don't give you which examples are these, but this is the West Pharmaceutical Company from the United States. But I found two case studies, and the second one is really, really similar to other cases in the past. So I hope that you will find these interesting. Now, what happened here? The first incident I'm talking about occurred in a pharmaceutical company on January 29 in 2003, where a dust explosion at this company, which manufactured small rubber parts for pharmaceutical delivery devices, actually killed 6 workers, injured 38 others, and that included 2 firefighters who were engaged in the emergency response in the event. Also, the damage caused by the explosion was so extensive that the manufacturing facility was severely damaged. A student at a school 1 kilometer away was injured by shattered glass. So that was the power of this explosion. Businesses located in the same industrial park were also damaged, and wind-borne burning debris ignited fires in wooded areas more than 3 kilometers away. So that is the effect that we are talking about. Now, the production operations included rubber compounding, molding, and extrusion. The facility manufactured rubber drug delivery components, and the fuel for the dust explosion was fine plastic powder. Let's see in a little bit of more details about what the investigation revealed. The company was very well aware of the rubber compounding process that could cause dusty conditions in the facility. And it's really positive that the company itself took extensive precautions to reduce dust accumulation. So they have very good intent. Additionally, because the facility produced supplies for medical use, good housekeeping was a high priority. Crews continuously cleaned dust from visible areas. They were vacuuming and wiping up dust on exposed surfaces. And also the company installed ventilation, dust collection systems at the mixers. So you see that they have very, very good housekeeping system in place, and they were really cautious about and very knowledgeable about the dust in the facility and the dust conditions. However, polyethylene dust, which is used in the process in slurry form as an anti-tacking agent, was also drawn upward through several ventilation air intakes located over an acoustic tile ceiling installed above the rubber production area. Above that ceiling, which was only visible to maintenance workers, approximately 1 ton of combustible dust built up gradually. The first explosion dispersed other dust accumulations into the air around the production area and ignited them, causing a more devastating secondary explosion and fires. So this was the first case. As you could see, that there was a very, very good procedure in place, good housekeeping, knowledge, everything about the hazards. Still, there was a hidden area where the company didn't consider that it would have been the case that dust could accumulate. Now let's see the second case. The second case, I inserted also a picture so that it is more visual for you. There was an accident in 2014 in August. A catastrophic dust explosion occurred in a large industrial plant for polishing various aluminium alloy parts. The explosion occurred during manual polishing of the surfaces of aluminium alloy wheel hubs for the car industry. It's quite a typical one, I think, and that's why I mentioned that similar to this accident, there was an earlier, a past incident that was really alike, and that's why the learnings are quite important. 75 people lost their lives immediately in the explosion, and another 185 were injured. In addition to that, subsequently, 71 of the seriously injured also died, which increased the total loss of lives to 146. Very devastating, very serious accident. A series of explosions was initiated in one of the external dust filters, which then propagated into the main building through the dust extraction ducting and reached the second floor. At the same time, the spreading flame was sucked into the ducts toward 7 other external dust filters, which also exploded. And here you can see on the picture all these dust filters, how they were positioned, and so quite a domino effect that occurred. Let's see what we can learn from this particular case. The investigation concluded that the explosion was most probably, because they couldn't identify the exact cause, but most probably it was initiated by self-ignition of contaminated aluminium alloy dust in the dust collecting barrel below the external back filter unit, in which the initial primary explosion took place. At the same time, neither the dust collectors, the dust extraction ducting, nor the electrical sockets were earthed. So in comparison to the previous case, in this particular company, there was no such a good housekeeping procedure in place. They were not aware of the importance of earthing such equipment, and so that was not such a knowledge available. And there was also another aspect here I wanted to highlight. There was a misconception about that dust explosions occur only if a large amount of dust is present. However, even quite thin dust layers can produce dust cloud within the explosive range. And that was, I think, a very crucial finding from the investigation, and also the scientific paper that analyzed the case. And there was another misconception in place, that was that dust not visible in air cannot explode. Good housekeeping and periodic dust removal could prevent accumulation of combustible dust, which would reduce the risk of dust explosions. So there are misconceptions around dust explosions, and I hope that in the What Can I Do session, I can highlight some of those. If you have more in practice that you would like to share, then please feel free to do so. This is, most of you, if you are familiar with the safety law, then you know that there is a second session of the safety law, the second page, that analyzes what can I do, and based on your roles within the company as a manager, process safety engineer, supervisor, or operator, there are some recommendations associated with the 6 elements of the iChemist safety framework. What can you do? And these are more targeted recommendations, so everybody feel the ownership and responsibility and leadership over these recommendations. So I have collected a couple of tips. Yeah, I know the slide is quite wordy, but I will give you the link later on, so you can download the safety law in PDF format, and there you can extract all the information if you need it for your trainings, for your colleagues to share with. So you can find all the information. Now these are examples. What can I do as a manager in order to avoid such cases where dust explosions occur in the facility? Please feel free to add any more if you have more. So knowledge about how dust explosion can occur is key in operation, and so ensure that employees are regularly trained on combustible dust hazards to keep their knowledge up to date. The explosion pentagon is a primary information in that regard, and I would like to highlight this because in some cases it may be that we tend to forget about the pentagon, but that is a basic information to hear and really important. In addition to that, develop and implement written operating procedures for dust maintenance and good housekeeping operations. Combustible metal dust can react exothermically with water. As such, avoid installing sprinkler system in facilities where combustible metals are processed. Ensure that facilities are designed in a way to minimize accumulation of dust and that spaces inaccessible to housekeeping are sealed. For example, segregating dust producing operations, sealing walls, ceilings, and using electrical equipment suitable for explosive atmospheres. Implement a hazardous dust control program that includes dust inspection, testing, and also housekeeping. Ensure to develop an effective permit to work system to control hot work, welding, and so on in the facility. And you can imagine that these recommendations are not only related to these two case studies, but they are also related to other cases as well in the past. So I collected these recommendations based on many other past incidents, and hopefully they are useful. And also, to reduce the buildup and spread of combustible dust, consider installing a safer dust collector connected to an efficient source capture extraction system. Extracting the dust in immediate proximity to where it is produced, source capture is an effective method of preventing dust from spreading. These are the examples. What can I do as a manager? And now we are going to see what can I do as a process engineer and a supervisor. Again, it's really worthy, I know. And as I said before, this is to share information with you. Please feel free to share your information, and also you can download the law later on. Ensure that you are trained on the hazardous characteristics of combustible dust, and that knowledge is transferred to operators working on the floor. Ensure that emergency procedures are well known to operators and that they follow safe operating procedures. If operators report dust explosion hazard, investigate it immediately and ensure the hazard is removed or addressed. Ensure controlling the use of open flames and static electricity, and obviously don't allow smoking. Dust is considered an undue hazard if it creates the potential for an explosion, and some of these conditions that may indicate the potential for an explosion, for example, dust build-up on floors or other surfaces, as we could see in the first case study, and the dust collector located indoors, as we saw it in the second case, and many others. Make sure that you check these locations on a regular basis, included in the dust control program. Make sure that regular monitoring and removal of dust are performed not only in primary areas where dust accumulates, such as on production floors, but also in other areas such as cable trays, ductwork, false ceilings, as well as behind equipment and other hidden areas that you may think about in your operation. I also collected some information about what, as an operator, I can do about dust explosions. And there are a couple of those as well here. As an operator, make sure that you are aware and that you are understand the hazards associated with combustible dust and about dust explosions. And should you see an accumulation of dust that you believe that could lead to a fire or explosion, immediately report the hazard to your supervisor or employer, and refuse to continue working until the situation is resolved. Make sure that work areas are kept clear of dust accumulations, and use vacuum cleaners specifically approved for dust collection. Avoid the use of sweeping brushes and compressed air, except for non-dusty cleaning activities. Keep heated systems and surfaces away from combustible dust. And these are the information I gathered around dust explosions. And I know it's quite general, but it may highlight some of the aspects that as operator or someone that is working in such areas may extend the knowledge about. So I think it's really important to talk about these issues. And as I said, if you have more information or more cases that you would like to share with us, with others who are here today, then please just type them in. In the meantime, until you type your questions or any other ideas or comments or past incidents that you would like to highlight for other people in the audience, I'd like to show you that this is the work we have done by the iChemist Safety Center, and those areas that we cover are competency, assurance, engineering and design, learnings, that is the safety law, there is education, and then also other materials such as virtual HAZOP, and now the new publication on Delta HAZOP that focuses on creeping changes, are all published here. And these are the guidance documents that are free to download from our website, and feel free to share them with your colleagues, as well as the safety law. And the latest version of the assurance one, which is lead process safety metrics about alarm rationalization, is coming up soon. It's going to be published in the next couple of weeks. The case studies are not for free, but these are interactive case studies that help to avoid hindsight bias when we talk about real past incidents. So these are the materials that may be useful. And of course, as always, you have the podcast and the PDF version of the safety law. And I know that this podcast or webinar was a little bit shorter, but this is a very, I think it's really a straightforward topic, and I hope that these recommendations and talking about the case studies will help to prevent these accidents. And I see that we have a question here, so let me just so there is a comment and a question. Surely part of managing the risk of dust explosions is to have hazardous area classification drawings and have briefed these to site teams. Yes, that's certainly true, that a briefing, and in fact that is a good reminder to mention toolbox talks. So that is also a powerful way of sharing information with workers and briefing them just before any work starts. And you know that it's really interesting that dust explosions can occur in many very wide areas of industries. And we shouldn't be ignorant about the fact that it can be, you remember the Imperial sugar dust explosion. It was a very famous, very well-known one. But there are chocolate crumbs explosions, other explosions in agriculture, in silos, obviously, wood, and also other cases. So it's really a wide area or call, for example. There is another question: how is Asia Pacific dust hazard compliance compared to US? I'm afraid I cannot answer to that question because I'm not familiar with either the Asia Pacific dust hazard compliance or the US one. However, if someone from the audience can answer that question, I would be really happy to see that suggestion or answer. So how is Asia-Pacific dust hazard compliance compared to US? For fluidized bed drying process, can we only rely on controlling the ignition source for some powder? Again, I would like to ask the audience, because I'm not expert in dust explosions. I highlighted the process safety aspects of it, but I'm very happy to see if there are other people who can. How do you see the importance of good grounding earthing systems? Oh yes, that is. I've also seen another case, not only the second one, where we have seen that there were no grounding and earthing at all in place. There was another case where the ducts, electrical systems, everything were old and obsolete, and they actually posed ignition source, and that's why I think when you, even with your boots or even with other material equipment that you touch that or create spark, that is a massive ignition source. So earthing and grounding have a really important role in this regard. I think it's really crucial. And also ventilation, fans that are ATEX or any other equipment that you use, like torch and all the other equipment should be specific to this particular hazard. Where would you include in your safety law provision to the emergency services on information on the material? For example, you mentioned exothermic reaction between combustible metals and water, and there is potential the firefighter will use water when fighting fire. Yes, this is really important, and I know from other learnings, from other past incidents, that firefighters may not be aware or may not be informed by the operator when they arrive to the scene to fight the fire about the characteristics of the material. And in fact, the important thing is that, and unfortunately, it is the case in many areas where the operator himself or herself is not aware of the hazards. They are not aware of the characteristics of those materials. So it's really crucial to have such an inventory of the stored materials and their material safety data sheet, which provide adequate information about those materials and the conditions for those cases where the plants are covered by either the Seveso Directive, COMA regulations, or any other specific regulations to prevent major incidents, they must have emergency response plan in place. However, other companies which are not covered by these regulations and still have such areas, and mostly in agriculture, I believe so, they also have to have such an inventory, at least for the sake of protecting their workers. So it's really important, and because we have to protect also the emergency response team. What types of engineered protections can be installed to minimize the risk of dust explosions? This is quite a specific ones. And how are different types of dust classified in terms of the risk they present? I think that there is a really extensive literature about dust risks and the classification of dust. And I may be able to find those for you. Currently, I cannot answer to that question, I'm afraid so. But there are, yes, there is a handout, yes. Okay, somebody raised hand, but I can't see any associated question. So the Spanish version of this safety law will come out soon, and I hope that I could cover mostly the topic. I know it's not as detailed as you would prefer to have on dust explosions, but the aim was to show you case studies and to look a little bit wider when you check what are the activities associated with dust explosions and how they can materialize, how they can occur. So thank you so much, and I hope that you found this session informative and interesting, and see you next time. Next safety law, I will bring 2 case studies about lessons from procurement and how procurement is involved and was involved in many case studies and learning from them. So thank you so much for your kind attention, and please feel free to send me questions if you have. Here you can see the details of the contact. Thank you again, and have a good day or good night.